All right, everybody. So we just talked about negative feedback loops. Let's talk about positive feedback loops now. So a big difference between positive and negative feedback loops is that, as mentioned, negative feedback loops bring you back to normal. They go up and down. Positive feedback loops are a little different. They still maintain homeostasis, but their job is to self-amplify. It's going to be an amplifying signal. All right. The goal is to, again, reach homeostasis, but by amplifying a certain signal. It's better with examples. An example here could be oxytocin, all right, as well as uterine contractions. Okay, this is my way of remembering it. The three P's of positive feedback loops. All right, this is it's a little crude, but it helps me remember it. Um, Pooping, peeing, pregnancy. They're not perfect, but they're all P's, and it helps me remember they're positive. What they have in common is they are self-amplifying signals. For example, if I'm hanging out here talking with you guys on the video, I may feel fine, right? Living the dream, doing my thing. A couple hours later, I'm still talking with you, and as time went on, my bladder continued slowly to fill over time. As it fills, the tissues are going to start to expand. And as they expand, they start to send signals to my brain saying, you have urine ready to be released, get to removed, right? At first, the signal's kind of weak. It's not too bad, right? I don't have to go that bad. But slowly, the signal gets more and more intense until finally I have to pee, right? When I go pee, I pee, release it all, and now the signals will decrease right back down to normal. So in other words, the signals are going to slowly increase and increase until eventually I hit that point where I can return back to homeostasis. Another example of this could be something like a pathogen, whether it be a bacteria or a virus, that's going to trigger fevers in the body. So one way your body defends itself is through body temperature. So many proteins that are in bacteria and in viruses can be denatured or broken down, right, destroyed with high temperatures. So one trick your body does is it just heats up, right? So if I have a virus in my body and it heats up, there's a very high likelihood that the virus is going to be destroyed just because of the heat my body generates. With that said, my body temperature is normal, but now it's going to increase in order to do a job. And once all those pathogens are destroyed and removed, or enough of them are, my body's going to go back to normal temperature. Obviously, you don't want to get too high, right? You don't want it to go too high. As you can see here, 108 is a pretty significant fever, and it can start doing additional damage to the body, all right? It's not a perfect process, but the idea is that's another type of feedback loop, okay? In the next video, I'm going to give you some visuals of both positive and negative feedback loops to hopefully nail that down. Let me know if you have any questions on this video.